Okay, so what does the coefficient of determination? Now look back. Now
I
find.
think
Okay.
I think it's the interpretation of the how well the regression model fits the observed data.
Yeah, how well the sample regression model fit the. Okay, so it suggests that our model, okay, our model, the model can explain, okay, 23.2% of the total variation in the dependent variable, which is wage. Okay, our model can explain 20.2% of the total variation in the dependent variable wage. Okay, in this wage, in this sample, remember that, just in this sample, not in the population. All right, our model can explain 23.2% of the total variation of the dependent variable wage around its sample means in this sample. Okay, so that is the meaning of R squared. All right, now that is questions 2 and 3. What about questions 5, 6, and 7 as well? Still, we have 3 more questions for exercise 6. Now, 5, 6, and 7. Đức Trung, Trung có điểm chưa?
Em chưa.
Okay, now let's help me.
Cô có thể đọc những điểm được không cô? Để bọn em cầm viết.
Đọc điểm hả? Đứa nào mà lên trả lời đúng thì có điểm. Trả lời đúng thì có điểm. Okay. Anyone who get a correct answers will have extra point. Okay. Now, who have just volunteered? Who have just volunteered for questions 5, 6, and 7? Okay, Đức Trung, right? Can you, what is it? All right. Okay, for questions 5. Now, Trung, for questions 5. What is the questions? The question here is, yeah, if we change the measurement unit of weight into $1,000, currently it is dollar. What are the new estimated coefficient? All right. Now, questions 5.
I think that the new estimated coefficient will be the old one divided by 1,000.
Okay, so now the current for when we use the unit for wage, if it is dollar, okay, the current unit, if it is dollar, what is the value of beta 1 hat and beta 0 hat?
For the unit dollar, the beta 0 hat is 2646.952.
Okay. And what is the value of beta 1 hat?
Is 60.214.
Okay. All right. So now if we use the unit, measurement unit for which is $1,000. What is the value of beta 1 hat and beta 0 hat?
I think we just simply take the O1 and divide them by 1,000 because now the unit is $1,000. So we just divide them by 1,000.
Yeah, so come back to the slide. We talked about the change in measurement unit. You can see that if we have a new variable, a new dependent variable, which is y star equal b times the new times the old dependent variable y. All right, then we will if we change the measurement unit of the dependent variables, then we will got new intercept and new slope. Okay, and the difference here is just times the O1. We take B times the O1s. Okay, so B here, what is the value of B here? If we have new, okay, we have new Y, okay, new dependent variables equal B times the O1, okay? So what is the value of B in this case? What is it?
Uh, 1,000.
No. Now, for example, we have the salary for a worker, the wage for a worker. We have an observation that is 3,000, for example, $3,000. If we use the dollar as the unit for weight, that observation will have the value of 3,000. But if we use the $1,000 as the unit for our wage, then that observation will has the value of 3, right? Now, so what is B here?
Is 1/1,000.
Yeah, it's 1/1,000. All right. And the new, okay, the new intercept and the new slope will be B times the O1s, right? That is 1/1,000 times the O1, that is 60.214, and is equal to 0. 0. What? 0.6, right? Okay, and this one 1/1,000, okay, times 2,646,952, which is equal to 2.646. Okay, so that is the new intercept. You guys get the same answers?
Yes.
Yes, okay. So in Starter, now in Starter, all right, I will show you how to do it in Starter. Let me import the data into Starter here. Now the stopwatch. Okay. All right. We have the. Now I will generate a new variables. Okay. a new dependent variables, which is which one. For example, I will use the command generate or gen. Okay, gen, then the new and space and the name of the new variables. You can put anything there. For example, I call it wage one. Example, equal. Okay, now equal the O1. Okay, equal the O1 and times B here. Okay, times B, and B is equal to 1 over 1000. So it means that we will divide weight by 1000. All right, we will get the new variable weight one here. You see that? Okay, we have the new weight one here. Now, simply, I will regress which one, the new dependent variables on the independent variable education. Okay, and then we have, this is the estimated result, the estimation output. Okay, I will copy it into what, so that you can see it better. Now, okay, so look at the code, new intercept and new slope. Here is the new intercept and the new slope. Okay, and you can do that on Stata. It is very quickly and easy. Okay, we get the new estimated slope and intercept. All right, that is questions. Now, what about question 6?
Question 6, the estimated value of the variance of the disturbance is the residuals is now 146,168.836.
Our questions, what is the questions here?
The question is, what is the estimated value of the variance of the disturbance?
Okay, what is the estimated value of the variance of the disturbance UI? Okay, and what is it?
Is the sigma hat square.
Okay, it is sigma hat square for questions. What is the questions? Questions 6. Yeah. Now we need to find the estimated value of the variance of the disturbance UI, and that is sigma square hat. What is it?
Is the intersection between the residuals rows and the MS columns.
Where is it? This one.
The 146,168.
Yeah, this one, right? This is the estimated value of the variance of the disturbance UI. It is the variance of the residuals UI hat, right? And it's equal 146,168.836. Okay, that is the estimated value of the variance of the disturbance UI. Okay. Now, if I ask you, what is the value? What is the estimated value of the standard deviation of the disturbance UI? So what is it? What is the estimated value of the standard deviation of the disturbance UI?
Is sigma hat, and it is the square root of sigma hat square.
And what is it? Do you see it in this table? Okay, you can do the calculation. You can see it right here in this table. Where is it?
Is the root MSE?
Yeah, right. It's the root MSE here, 382.32. Okay, 382.32. That is the standard error of the residuals, and it is used as the estimated value of the standard deviation of the DWIs. Okay, all right, that is question 6. And what about question 7? Question
Uh,
6. Yeah.
about question 7, I think we will base on the other variables in the data. So we have age, race, experience, I think,
Mm-hmm.
IQ, sex, marital status, and some other variable that I'm not really sure what are they.
Okay. So here, in addition to years of education, we can see that there's many other factors that affect the value of the wage, right? And actually, those you can find those factors based on previous studies, not using the data I provided you. All right. Okay. So based on previous study, you can see that there's plenty of other factors that affect the value of the dependent variable wage. Okay. So it can be seen that, and it can also be seen that the coefficient of determination of this model is just over more than a little bit more than 20%. Okay, it means that only education is not enough to explain the variation in the value of dependent variable wage, right? So in a better situation, a more ideal situation, when we have the information of other factors that affect the value of wage, and we have the data of them, all right, we can specify, we can construct a model that has more than one the independent variables to explain for the value of the wage. Okay, and that model which have more than one independent variables, we call it the multiple regression model, or we can call it the multiple variable regression model. And that will be the things we will study in chapter 3. Okay, that is will be the content of this lecture. All right, thank you, Chung. All right, I will give you an extra point. Chung, yeah, all right. Now, okay, I have post the material, the slide for chapter 3 here. You can download it, all right, in the channel general and class materials. I have posted the slides for chapter 3, and we will study chapter 3 today. Do you have any questions regarding the practice exercise?
I have just a small question
Mm-hmm.
about the how do I say it? The estimated the standard error of the estimated slope.
Mm-hmm.
If we account that, does the slope just rotate around the around its how do I say this?
You can say it in Vietnamese.
Yeah, but there are my but there are exchange students in the class, so I do not want them to miss the Yeah. So um, with that standard, the error does sorry, with that standard deviation, does the slope rotate around the O point, the 0, 0 point? I mean, if we take that into account, so the range of our guess would be like when the slope rotate around the zero
Mm-hmm.
point.
Okay, so for the standard error of the estimated slope, all right, now let's do it. Okay, so we have the estimated slope beta 1 hat is equal to 60.21, and we have the standard error of beta 1 hat, for example, is 5.69. Okay, for all right. So what does it mean? Okay, so you can see that we beta 1 hat is a random variables for each okay, so it can take on various. So that is the value of beta 1 hat. All right, so beta 1 hat here has the expected value of beta 1. Okay, all right, and our purpose here is to find the value of beta 1. All right, now if this one has a high value, okay, which is about 60.21 like this, and the standard error of it is just 5.694. Okay, it means that, okay, um, um, if this one, if beta 0 hat, okay, is equal to beta 1 here, okay, then the observations of beta 1 hat, okay, will be quite close to the actual value of beta 1. Okay, usually in statistical estimations, we have this one is the point estimate of beta 1. All right, and but actually the actual value of beta 1 can be different from this one. It is just the point estimate, so that we can imagine where is the beta 1. Okay, but actually the actual value of beta 1 is different from this one. All right, so beta 1 can be here and beta 1 is here. Okay, it is different from each other's. Okay, so in order to know more about, to understand more about the actual value of beta 1, okay, we usually use the standard error of beta 1 hat. We will open a range around beta 1 hat like this. This beta 1 hat that we found from the sample data. Okay, for example, we usually open a range around beta 1 hat. Okay, that is usually t times the standard error of beta 1 hat like this, and t times the beta 1 hat minus t times standard error of beta 1 hat, and beta 1 hat plus t times the standard error of beta 1 hat. Okay, this one is here and this one is here. Okay, we usually open a range around the point estimate, and we believe that maybe at 95% or 99%, for example, okay, 95% sure that the actual value of the beta 1 will be within this range. Okay, so if the range is small, and which means that the standard error is also small. Okay, so we will have a quite small range. Okay, and that range is possibly, okay, 95% surely that range will have the true value of beta 1 above beta 1. Okay, so it means that when we have a small standard error, okay, we will have a good estimate, a good point estimate of beta 1. Okay, all right. But if we have a large standard error, which means that the range around beta 1 hat must be big like this, must be large like that, so that it can this range can have the actual value of beta 1. Okay, so beta 1 can be here, beta 1 can also be here, which means that the point estimate here is very far from the actual value of beta 1. And that will be a bad estimate, not good estimate of beta 1. Okay?
Okay, so I mean, the question I asked earlier was about the graph. I mean, if we demonstrate the estimation of B1 of beta 1 on the graph, it's like a line. But then when we take into the account the standard error, does it does the estimation range just rotate around the foot of that line? I mean,
Which
just
line?
the line
Which?
of I mean the line is the slope, the beta 1 slope. Like when we take into account the estimation, does that slope just rotate to demonstrate our range?
Actually, I don't understand your questions.
Ý em là khi mà mình biểu diễn cái function đấy lên trên một đồ thị ạ, thì cái slope, cái độ dốc của beta 1 là 60,21. Nhưng mà khi mà mình tính vào cả cái standard error thì có phải là cái đường dốc đấy nó sẽ rotate quanh cái chân của đường chéo lên được không ạ?
Okay.
Hay là nó sẽ tịnh tiến ạ?
Nó không tịnh tiến và nó cũng không rotate, nó còn tùy thuộc cả vào cái thằng beta 0 hat của em nữa. Nó còn tùy thuộc cả vào cái thằng đấy nữa, nó có thể vẫn một cái đường như này. Đó là
Em là
cái,
assume,
hoặc
ý
nó
em
như
là mặc định là beta không đổi thì nó sẽ kiểu rotate.
ok, nếu mà
Thì
beta không đổi, nếu mà beta không đổi thì nó sẽ là rotate quanh cái điểm này. Đấy, ví dụ như đây là beta 0 của mình nhé, nó sẽ rotate như thế này. Nhưng mà đấy là assume là beta không đổi, mà actually là beta 0 nó sẽ thay đổi. Bởi vì mình cũng not sure vào beta 0 như là cái thằng beta 1 của mình. Yeah. All right. Any other questions? Okay. So let's start with chapter 3, multiple regression model. Okay, so in chapter 1 and 2, we have studied the simple linear regression model, or we can call it the two-variable regression model. Okay, you can see that the two-variable regression model is very easy to specify, and it is also easy to estimate that model. Okay, we have just two very simple formula to calculate the estimated value of the slope and the intercept. Okay, but we can also see that from exercise 6, we see that a two-variable regression model is usually not strong enough, not enough to explain the variation of the dependent variables. In a more ideal case, in a better situation, when we have the information about other factors that affect the value of the dependent variables, and we have the data for them, we can have a model that have more than one independent variables to explain for the dependent variable. And those model will be called the multiple linear regression model. Okay. All right. Now let's begin with the most simple, the simplest multiple regression model. Okay. That is the 3-variable regression model. Now we have the population regression function is like this. Okay. The population regression function. We still have the conditional expected value of y of the dependent variables. Okay, and this expected value is conditional on the given value of x1 and x2. Okay, now we have two independent variables, that is x1 and x2. All right, and the conditional expected value of y conditional on the certain value of the independent variables is equal to beta 0 plus beta 1 times x1i plus beta 2 times x2i. Okay, so it's quite the same as the 2-variable regression model. The only difference here is that we have one more independent variables, and we have one more independent variables, and the coefficient and the regression coefficient associated with that new independent variables. Okay, we call it the regression coefficient or the slope is also okay. Now, for the population regression model, we still have one more form of it, that is the stochastic form of the population regression model, where we have the observed value of y, the random value of y is equal to beta 0 plus beta 1 times x1i plus beta 2 times x2i and plus the disturbance ui. All right, so it's quite the same as the 2-variable regression model. Okay, we have y here is the dependent variables. We have two independent variables in this model, that is x1 and x2. Okay, we have the coefficient beta 0, beta 1, and beta 2. With beta 0 is the intercept, okay, or the constant, and beta 1 and beta 2 are the two regression coefficients. Okay, we call it partial regression coefficient because it will show the partial effect of each independent variables on the dependent variables. Okay, and we have ui here is the disturbance of the model. All right, it's quite the same. Yeah, and for this, what will be the sample regression model of a 3-variable regression model? What will be the sample regression model for this? The corresponding sample regression model. What is it? What is the corresponding sample regression model in this case? Now, anyone who can help me with this? The corresponding sample regression model.
This is xi hat equal beta 0 hat.
Xi or yi?
yi hat, sorry, yi hat
equal
beta 0 hat.
Yeah, beta 0 hat.
Plus beta 1 hat
It's
One
beta
I
hat times x1i.
Plus beta's 2 hat x2I.
Yeah, we have beta 2 hat times x2i. Okay.
Yes.
Yeah, and
And
that is the sample regression function. And we also have the stochastic form, yeah, of the sample regression model. It is yi equal
y equal to the wait for me. Y equal to beta 0 hat
yep.
plus beta 1 hat x1I plus beta 2 hat x2I and plus ui hat.
X2i and plus ui hat. Okay, that is the stochastic form of the sample regression model, right? Now, and as you can see, we also have three estimator. We have three OLS estimator of the unknown parameter here. Okay, those one, beta 0, beta 1, beta 2 are the unknown parameters. Yeah, because we don't have the data for the population, so we call it the unknown parameters. Okay, including the intercept and the regression coefficient and those beta hat. Okay, those beta hat, beta 0, beta 1 hat, and beta 2 hat. Okay, they are the estimators. Yeah, estimators of the unknown parameters. Okay, all right, that is the three variable regression model. Now, here we have the meaning of the partial regression coefficient. We call beta 1 and beta 2 are the two partial regression coefficients because it shows the effect of only one independent variables on the dependent variables. Now, for example, beta 1. Beta 1 measures the change in the conditional mean value of y per unit change in x1, holding the value of x2 constant. Okay, because we are holding the value of x2 constant, beta 1 will be the effect, is the effect of the change in x1 only on the dependent variables. Okay, it is just the effect of x1 on the dependent variables. Okay, now you can see that beta 1 here is the first derivative of y with regard to x1, right? Is the change in the conditional mean value of y per unit change in x1. All right, so it means that when we increase x1 by 1 unit and keep other variables constant, which means that we keep the value of x2 constant, then the expected value of y will increase by beta 1 unit. All right, that is the meaning of the partial regression coefficient. It's different from the two variable regression model because in the two variable regression model, we have only one independent variables. But for multiple regression model, you will have many independent variables in the model. That's why we have to make the difference. We have to tell the difference between the estimated slope here. Okay, each slope will show the effect of a certain of the associated variables, independent variables, on the dependent variables. Okay, and similarly, we have beta 2 here. Measure the change in the mean value of y per unit change in x2 while we're holding the value of x1 constant. Okay, now we have beta 2 as the first derivative of y over the with regard to x2. All right, and it means that when we increase x2 by 1 unit and keep x1 constant, okay, the expected value of y will increase by beta 2 unit. And so beta 2 shows the effect of only x2 on y. All right. Remember that when you explain the meaning, when you tell the meaning of those slope of the partial regression coefficient, remember this what holding or keep other variable constant. Okay, we only change the value of that independent variable, okay, and keep the value of other independent variables unchanged. All right. Okay. Now, that is the specifications of a 3-variable regression model. Now let's move to the estimation of that regression model. Assume that we have a sample of n observations in hand, okay? And we have to estimate that model, okay? Because we do not have the data for the whole population. We just have a sample data. That's why we have to estimate the model, okay? Now, estimate the model or estimate the partial regression coefficient. What is the method that we used to estimate a 2-variable regression model? Do you remember the name of it?
OLS methods.
Yeah, OLS, the ordinary least square estimation method. We use the OLS estimation method to estimate linear regression model. So is this model a linear regression model? This one, a linear regression model.
Yes.
Yes, yeah, we can see that all the parameters has the power of 1, right? Then it is a linear regression model. And because it is a linear regression model, we can still use the OLS estimation method to estimate this model. All right. Now, we will use the OLS estimation method to estimate the model. Okay. And we will identify the sample regression model here by choosing the value that minimize the value of RSS. Okay, so for this 3-variable regression model, what is UI hat? What is UI hat? What is UI hat here?
The residual of the function.
Yeah, it is equal. Yeah, UI hat, the residual is equal to the difference between the actual value and the estimated value, is it? And it is equal to, okay, yi minus, what is the estimated value in this case?
YI hat.
Yeah, yi hat. And what is yi hat equal to?
YI hat is equal to x
These are
beta 0 hat
0 hat.
minus beta 1 hat x1i.
Yeah.
Minus beta 0 hat x2i.
Beta 2 hat multiplied by x2i. Okay, so this is our residual UI hat. Okay, and the residual sum of square here will be equal to the sum of all the difference between yi minus beta 0 hat minus beta 1 hat times x1i minus beta 2 hat times x2i. Okay, and square. All right, now we have to find beta 0 hat, beta 1 hat. Okay, and beta 2 hat that minimize this one. Okay, minimize this expression. All right. What will we do here? You still remember? How can we do to find the value of beta 1 hat, beta 0 hat, and beta 2 hat that minimize IS?
We use derivation of x and y respectively.
Yeah, so we take the first derivatives of IS with regard to beta 0 hat, beta 1 hat, and beta 2 hat. Yeah, correctly. All right, what do we have here? Yeah, there's our IS here. All right, and now we will take the first derivative of IS with regard to beta 0 hat and beta 1 hat and beta 2 hat. Okay. All right. Okay, I make a mistake here. It should be beta 2 hat here. All right. Oops. Okay, we will find those to minimize the sum, the residual sum of square. We will take the derivative and we will have three equations. Okay, we will have three equations and we solve for three unknown roots. Okay, and we have to solve for the value of three roots. A set of equations with three equations and three roots. Can we solve for the roots? Can we solve this set of equations?
Yes.
Yeah. As long as the number of equations is equal to the number of roots, we can solve for this set of equations. And using some mathematical techniques, we can get this is the root of that set of equations. We have beta 0 hat is equal to y, the sample mean of y, minus beta 1 hat times the sample mean of x1 minus beta 2 hat times the sample mean of x2. Okay, and here's the formula to calculate beta 1 hat and beta 2 hat. Okay, all right, where x1 small, x1 small is the difference between the actual value of x, the observed value of x, minus the sample mean of x. And the small y here is the difference between the observed value of y and the mean value of y. Okay, you have to calculate those small x and small y and calculate the products between them and sum all the products and we will get this one. Okay, now imagine that you have a set of data. Okay, you have a set of n observations. So can you calculate the value of beta 0 hat, beta 1 hat, and beta 2 hat? Can you calculate them? Imagine how you do it. Is it an easy task? Yeah, it is an easy task when you have to calculate the value of beta 1 hat, beta 0 hat, and beta 2 hat. Okay, now here, example. We have a set of data for, what is it? We have three variables here. DI is the sold dozens of roses in a week. PI is the price of roses, and INI is the average weekly income of a household in the area. All right. And DI here is the sold dozen of roses in a week at a shop. All right. Now, based on relevant economic theories, what do you think will be the dependent variables? And what will be the independent variables here?
The income will be the dependent variable, and the DI and PI will be the independent variable.
Now, why? Remember that the DI is the doesn't process in a week at a shop. All right. And I here is the average weekly income of a household in the area where the shop is located. Okay, more specifically.
So I think that DI will be the dependent variable, while the PI and INI will be the independent variable.
Yeah, okay. So you think that DI here is the dependent variable and PI and INI are the independent variables that can explain for the value of DI. Okay, all right. So DI here will represent what factor?
Why?
DI represent what factor? What factor you have learned in microeconomics? The demand quantity, right? It will be the demanded quantity. Yeah, PI when the price of the products, and INI here will represent the income of consumer, right?
Yes.
Yeah, all right. Okay, so based on microeconomics theories about the demand, okay, about the demand curve, we can see that here we can use the DI variable as the dependent variables and PI and INI as the independent variables of this model. Now, can you use this sample data to estimate? Now, okay, firstly, let's specify the population regression model first. What is the population regression model here? As we have DI is the dependent variable and PI and INI are the independent variables. What will be, the population regression model?
DI equal to beta 0.
Beta 0
plus beta 1 PI.
Yeah, beta 1 PI, yeah.
And plus beta 2 INI.
Yeah, beta 2 INI.
Sorry, beta 1 PI 1.
PI is good. Okay.
Sorry.
Yeah. All right. And let's start one more.
Plus U1.
UI.
UI, sorry.
Yeah, plus UI. All right. So this is population regression model. Now we want to know about the value. We want to find more about the value of beta 0, beta 1, and beta 2 to understand the relationship between PI and D and also the INI and D. Okay? All right. Now, that's why we have to estimate this model. We have a sample data here. We have the sample data here. Now, please use this sample data to calculate the value of beta 0 hat, beta 1 hat, and beta 2 hat. Can you do that? Is it an easy task?
No.
It takes time. It takes a lot of time.
It will take a lot of time and effort, and there will be then error may easily occur. Yeah, that's why For multiple regression model, you don't have to manually calculate the estimated coefficient. All right. For two variable regression model, you have to remember the formula to calculate the estimated coefficient. But for multiple regression model, you can use data to estimate that model. Okay. Now, this is how we can use, we can do it manually. You have to calculate the value of x1 small, x2 small, and y small. Okay, then calculate the square of small x1, the square of small x2, and so on for each observation. And then you sum all of them, you will get the inputs you need to calculate the value of the estimated coefficient, and just plug in the number into the formula. We will get the value of beta 1 hat like this, and beta 2 hat, beta 0 hat, and we will have the sample regression model here. Okay, but more easier now, you can do it on your computer. I will post, okay, I will post the data here. Here, you have the data. I will post it here. You can download the data and do it in Excel. From exchange student, I'm sorry because some of this is in Vietnamese, but you can just copy the data. All right. Sorry, I can erase it. And I will change the name of those variable a little bit so that you guys can easier get it. Okay, observation. Yeah, and demand. We have price, income, okay. All right, I will post it again. Okay, this is the data, and you can use this data to estimate our three variable regression model in Stata. Okay, now let's try it to see whether it will be faster, it will be easier to estimate using Stata. Now, anyone can share your screen with the class to see how you can do it and read the estimation output. Interpret the estimation output. Any volunteer? Okay. Văn Huy, okay.
Làm trên Stata hả cô?
Ơi.
Làm trên Stata ạ?
Yeah. Just do it in Stata. We can share your screen and do the regression on Stata.
Yeah, teacher.
Yeah, you can do it from the beginning. You can erase, you can clear the data you have here and do it from the beginning.
Okay.
Just enter the command clear.
Yes, teacher. Can you hear me clearly?
Yeah.
Yeah. First, I will import the data.
Yeah. Clear the data you have here first.
Okay.
Or you can close this section and open new section again.
Okay, teacher. Wait a minute.
Yeah. Okay, I can
Yeah.
see it
Yeah,
now.
I'm back. Can you see my screen?
Yes.
Yeah. First, I will import the data.
Yeah.
Okay. Okay. So yes. Regression. Yeah. I can start. The first the dependent variable here is.
Actually, I didn't see your screen moving, changing.
Yeah. Can you see my screen?
Your screen is still the same as I see it from the first place.
Yeah. Yeah. I don't know why, but maybe my connection is not good.
Okay, but guys, students, can you see Hui's screen?
Yes, but
yeah, but it's not moving.
see the mouse. Perhaps if he like type in the comment, maybe it will like something will appear. I'm not sure.
I don't know what to do with this situation.
Okay.
Or you can stop screen sharing and do it again.
Okay.
Stop. Yeah. Oh, I see it moving now. Yeah, and again.
Yes, here I'm back.
All right. Okay.
I will choose the dependent variable here is the demand. And the two independent variable here is price and the income.
Mm-hmm. Good.
Then I will have a Z table. First, here is a here is a beta 0.
Mm-hmm.
Here is a beta 1. Here is a beta 0 hat. Here is a beta 1 hat, and here is a beta 2 hat.
Mm-hmm.
And and from that we can have a sample regression model equal to
Even it is easier to use data to estimate than doing it manually, right? Okay, thank you. Okay.
yeah.
Mm.
Thank you, teacher.
Yeah, thank you, Huy. Let me share my screen. We will continue. Okay, so here we have the sample regression model, and we have the estimated coefficient here. All right. So what is the meaning of the estimated slope associated with P? What is the meaning of the estimated slope associated with P? Now, what is the value of the slope? What is the estimated value of the slope associated with P?
There's two variables like P, I, and I. So perhaps they are two slopes.
Sorry. I'll correct this a little bit. Sorry. One. Okay, so now look at the sample regression model here. You can see that this P, our independent variables, okay? This P, the independent variables, and the coefficient associated with P is beta 1, okay? And the estimated value of beta 1 is here minus 20.1. And what does it suggest? Beta 1 hat is equal to minus 20.1. What does it suggest? Now, remember the meaning of the partial regression coefficient. We have just discussed the meaning of the partial regression coefficient. What does it suggest? When
inverse relationship between the price and demand.
Yeah, the inverse relationship between price and demand. And also it shows the effect, okay? It shows the effect of price on demand, okay? And what is that effect?
With every one unit increase in price, there's a 20.1 unit decrease in demand.
Unit increase in price. Okay, that will be an increase
A decrease, right?
also a
It's an
decrease, sorry.
inverse.
Yeah, a decrease. Oops, what's it? There will be a decrease of 20.1 units in what? In demand.
Demand.
Yeah, in demand on average. And what else? And we still have one more thing to say. Remember that there is the partial regression coefficient.
And if the price stay constant or constant,
Yeah.
when the income increased by 1 unit, the total demand increased by 0.1 unit.
Wait. We are still with beta 1 hat. We still have one more thing to say here.
Others constant.
Okay, other constant. Okay, other being constant. Okay, which means that there will be no change in the income, in the level of income of the consumer. Okay, that is the meaning of partial regression coefficient. Okay, if price increased by 1 unit and other things being constant, okay, there will be a change. There will be a decrease of 20.1 unit in demand on average. Okay, and similarly, you can interpret the meaning of the estimated beta 2. Okay, we have beta 2 hat is equal to 0.1. Okay, it means that when the income of average household increased by 1 unit and the price of roses is unchanged, okay, the demand for roses will increase by 0.1 unit on average. Okay, I can write it here. When income of an average household increase by 1 unit, okay, and the price of roses is unchanged. Okay, the demand for roses will increase by 0.1 unit on average. Okay, all right, that is the meaning of beta 2 hat. Okay, here is the meaning of beta 1 hat. Okay, all right. Remember that while we increase the value of one independent variables, you have to keep the value of other variables unchanged. Okay, and then the change in the dependent variable will be the effect of that only independent variables. Okay, all right. Now, you can say that you can see that for different sample, you will get different value of the OLS estimators. Okay, and that's why here we are having the point estimate for our unknown parameters, and okay, we still have to evaluate the precision of those point estimate. Okay, we have to evaluate the precision of those point estimation. All right, and how can we measure the precision of our OLS estimator? What is used to measure the precision of our OLS estimators? Do you remember it?
The variance of the
variance.
estimator.
Yeah, the variance and the standard deviation of our OLS estimators. Okay, and the formula for the variance and the standard error of the OLS estimator is here. This is the variance of the intercept beta 0 hat, and this is the variance of the slope beta 1 hat and beta 2 hat. Okay, now look at these formulas. What do you see? What do you see here? What are the factors that affect the precision of our OLS estimators for a multiple regression model? For a 3-variable regression model here, what are the factors that affect the precision of our OLS estimators?
The range of observed value.
Okay, so we have here the first one. All right, the first factors is the variation in the value of the independent variables. Okay, the variation in the value of the independent variables, the sum of all small x1 square and the sum of all small x2 square. Okay, we call it the variation in the value of independent variable. Okay, and how does this affect? How does it affect the value of the variance of the OLS estimators?
The wider the variance, the less precise the LOS is.
Look at this. Look at this formula. It will be easier to judge. When we have higher value, higher variation of the independent variables, okay? When we have higher variation of the independent variables, what happens to the variance of the OLS estimators? What happened when we have higher variation of the independent variables? Okay, what happened to the variance of the beta hat?
Smaller.
The variance of beta is smaller.
Yeah, it is smaller, and our OLS estimator will become more precise. Okay, more precise. And that is the first factor. And the second one, what else? Look at the formula.
The variance of UI.
Yeah, the variance of UI. Sorry. The variance of UI. Okay, the variance of UI, the disturbance UI. Okay, so how does it affect? the precisions of OLS estimator. When we have higher variance of UI, then the variance of beta hat will be
higher.
higher, the largest. Then we will have less precise OLS estimators. Okay, the third one, what is it? We still have one more thing in this sum. What is it? One
The
more thing.
variation of independent variable.
Yeah, here we have the variation. We have the variance, the variation of the independent variables already. What else do we have in this sum?
Correlation coefficient.
Okay, the correlation coefficient between x1 and x2. Okay, and one more thing, like the two variable regression model. What is it? One more thing.
The sample size.
Yeah, the sample size. And yeah, when we have more observations, okay, the variance of the beta hat will be smaller, and we will have better estimators of the unknown parameters. Okay, and one more thing, compare to two variable regression model. Okay, we have one more things that affect the precisions of the OLS estimators. That is the correlation between the independent variables. Okay, the correlation between the independent variables R1, 2 here. Okay, and R1, 2 here is the correlation coefficient between x2 and x1, or we can say that that is the correlation between the independent variables of the model. Okay, so how does this correlation affect the precisions of our OLS estimators?
If it increases, the OLS is more reliable, more precise.
Yeah, correlation between the independent variable. Okay, so here you can say that look at the formula when we have higher correlation, because our correlation coefficient has the value from -1 to 1. So the square of the correlation coefficient will have the value from 0 to 1. Okay, and what happened when this one equal to 0?
Then the variance is
Will be smallest, other thing
yeah.
unchanged. Yeah. Okay, and what happened when this one increase and equal to 1?
Close to 1 or equal to 1.
Yes.
If it's
How
equal to
about
1,
the
then
case? Yeah, how about the case when it increased more than 0? Yeah, when this one increased, the variance of beta hat is also increasing. Okay, and what happened when this one equal to 1?
if it is equal to 1, I think it is 2 perfect.
Yeah, if this one is equal to 1, we will have 0 in the denominators, right? Your signal is not so good. I cannot hear you saying anything. All right. So now, all right. So when we have this one is equal to 1, okay, we will have 0 in the denominators. And it means that this variance is in what is infinite. Yeah, it is infinite. We cannot identify the value of the variance of the OLS estimators. In that case, because the OLS estimator is too what is too inaccurate, is too inaccurate, and you cannot specify the specific value of the beta hat. It means that when there is a perfect correlation between the independent variables, we cannot calculate the value of beta 0 hat and beta 1 hat. And we call that situation the situation of perfect multicollinearity. Okay, so multicollinearity is about the correlation between the independent variables in the model. Okay, and when we have perfect multicollinearity, which means that there is a perfect correlation between the independent variables, yeah, then we cannot calculate the value of beta hat. All right, and you will learn more about multicollinearity in econometrics too. In this course, we do not learn about multicollinearity, but just remember that multicollinearity is about the correlation between the independent variables. All right. Okay. So compared to two variable regression model, in two variable regression model, we have three factors that affect the precision of our OLS estimator. That is the sample size, the variance of the disturbance UI, and the variation of the independent variables. But for multiple regression model, we have one more thing. Okay, we still have that three factors. Those three factors still affect the precision of our OLS estimators. But we have one more factors that we care about here. That is the correlation between the independent variables. In multiple regression model, we have more than one independent variables. So there will arise the correlation between the independent variables. And if we have a high correlation between the independent variables, okay, our OLS estimator will be less precise. All right. That is the factors that affect the precision of our OLS estimators. Any questions here? Okay, I will write it here. Higher correlation, which means we have higher value of higher correlation. Okay, which means that we have higher value of R12 square. Okay, the variance of our beta hat will be higher, and we will have less precise OLS estimators, less precise estimate. Okay, now any questions here?
Cô cho em hỏi là ở cái mẫu ấy ạ,
Yeah.
nó là tổng của tích hay là tổng của cái variation rồi nhân với cái kia?
Tổng của variation. No, this is not the variation. This is just the sum of observed value of x minus the sample mean square. Okay, and multiply by 1 minus R12 square. Okay, thực ra thì nó sẽ là gì ạ? Nó sẽ là ở từng quan sát nhé. In each observations, you have to calculate the value of x1 square. Okay, in each observation, you have to calculate the value of x1 square, and then you sum them up. Okay, and then multiply by this one. This one is a constant. Okay, for a sample, this the correlation between x1 and x2 is a constant number, right? So 1 minus R12 square here is also a constant. You can put it here or you can put it before the sum is also okay.
Okay, thank you.
Yep. Any other questions? All right, so remember it. We have 4 factors that affect the precision of our OLS estimators. All right, so next. Assumptions of the classical linear regression model for 3-variable regression model. Do you still remember the basic assumptions for 2-variable regression model?
Yes.
Yes. Okay. So what are they? The first one, the model.
The model is linear in the parameters.
Okay, the model is linear in the parameters. Okay, so for 3-variable regression model, we still have this one. Okay, the model is linear in the parameters. The second one, x are fixed in repeated sampling, which means that when we put the independent variables into the model, their value must be known, must be fixed. Okay, all right. And the third one, we have 0 mean value of the disturbance UI. Okay, now this is the conditional mean of of UI. Okay, conditional on the certain value of x1 and certain value of x2. Okay, we have 2 independent variable here, and that conditional expected value of UI is still equal to 0. Okay, the fourth assumption here is that we have homoscedasticity of the disturbance UI, which means that the disturbance UI has constant variance across any observed value of x1 and x2. Okay, and it will be still sigma square here. Okay, we use sigma square as the name for the variance of the disturbance UI in the course. All right, and the fifth assumption here is that we have no correlation between the disturbance. Okay, so the value of the disturbance in these observations is independent of the value, has no correlation with the value of the disturbance in another observations. Okay, they are independent. Number 6, there's no perfect multicollinearity in the model. Okay, so we have just said that multicollinearity is about the correlation between the independent variables in 3-variable regression model, and also in other multiple regression model. We have more than one independent variables in the model. That means that there will be a correlation. There may be a correlation between the independent variables, and it is usually the case in practice. All right. And our assumptions here is that there's no perfect multicollinearity. Yeah, no perfect multicollinearity in the model. It means that we do not have the perfect correlation between the independent variables. Okay, the correlation coefficient between the independent variables is different from -1 and 1. Okay, that is no perfect multicollinearity, because later when you study econometrics 2, you will see that in the case where we have perfect multicollinearity, we cannot calculate the value of the beta hat. All right. Now, and the last one, the model is exactly specified. Now, in this case, we will care more about what are the independent variables that we need to bring into the model. Okay, so in the two variable regression model, you have only one independent variables. But for multiple regression model, you can bring many independent variables into model. Okay, and you have to bring, and we also say that we do not want to bring too many independent variables into the model, because it will cause many problems here. But still, you have to have the important variables in the model. You have to have important variables in the model. So what are the important independent variables? Okay, to answer these questions, you have to use economic theories. You have to you have to take advantage of the makes use of the previous researches to identify what are the important independent variables for your model. All right. And also you have to specify the functional form of the population regression model also. Okay, that are the basic assumption of the classical linear regression model. All right. Remember that if you do not have the important independent variables in your model, the slope or the regression coefficient here will not be the best. Yeah, the OLS estimator here will not be the best estimators for the unknown parameters. Right? Any questions here? Okay, no? All right. So I will move on. Yeah. The coefficient of determination R square and the adjusted R square. Okay, so we have discussed about the coefficient of determination R square in the previous lecture in the chapter for two variable regression model. And we have just do the exercise at the beginning of this class. Okay, and can you tell me again, what is the meaning of the coefficient of determination? What is the information it provides us with?
That represents the proportion of the variance for a dependent variables that explained by an independent variable or variables in a regression model.
Yeah, right. It will tell us about the proportion of the variation in the value of the dependent variables. Okay, that is explained, that is estimated by the one independent variables for two regression variables, as for two variable regression. And for multiple regression, you will see that it will be the explanations of the whole of all the independent variables. All right. So shortly, it tells us about the proportions of the dependent variables that is explained by the model. All right. So do you still remember the formula to calculate R square? What is it? The formula to calculate R square.
R squared equals to ESS divided to TSS.
Yeah, R square equal the ratio between ESS and TSS. Okay, or we can calculate it as the difference between 1 and the ratio between RSS and TSS. Okay, here is the formula to calculate R square. And in the case of a multiple linear regression model, okay, R square here will tell you about the proportions which all the independent variables jointly explain the variation in the independent variables. Okay, not only one independent variable, but all the independent variables jointly explain the variation in the dependent variables. Okay, And the meaning of it is still that, okay, is not different from the two variable regression model, okay. But there's one thing, the problem with R square. So do you want R square to be high?
I think yes.
Yes. Okay. So remember one thing. Remember one thing. R square tells us about the goodness of fit. Okay, between the sample regression model and the sample data. Okay, it tells us about how the sample regression model fit the sample data. Okay, and it does not tell us anything about the how the sample regression model fit the population, or how the population regression model fit the population. Okay, it just tells us about how the sample regression model fit the sample data. All right, so sometimes when we want R square to be high, when we try to make R square to be high, okay, the form the model, okay, may not be the model that we want in the population regression model. Okay, for the population, that may not the most appropriate uh, model for the population. Okay, because sometimes, because there's problems with R square here. R square is a non-decreasing function of the number of independent variables in the model. What does it mean? R square is a non-decreasing function of the number of independent variables in the model. What does it mean? It means that when we add more independent variables into the model, R square will be increasing, or at least it does not change. Okay, so it means that when we add more independent variables into the model, R square of that model will increase, or at least it does not decrease, or at least it stays unchanged. Okay, it will stay unchanged if the estimated slope associated with the new independent variables is equal to 0. If the slope, if the estimated slope associated with the new independent variables is different from 0, R square will definitely increase. All right, so it will lead to the case that we always want to add more independent variable into the model. And you also see the problem with many independent variables in the model. We will have more problem with the model at that time. All right, then when will we add more variable into the model? Okay, that is the questions that we need to answer. All right. Okay, so how to make you understand it? Sometimes it is good to add one more independent variable into model if that independent variables does have an effect on the dependent variable in the population. Okay, it means that it is good to add an independent variable into the model if in the population there is the effect of that independent variables on the dependent variables. Okay, in that case, you can add that variable, that independent variable, into the model. But there is the case when the independent variables that we add into the model does not affect the value of the dependent variables in the population. Okay, and it means that, okay, when we add that value, that variables into the model, it will make the population regression model less appropriate. Okay, so it is not always good to add more variable into the model. Okay, so when should we add one more independent variable into the model? If we use R-square as the criterion to answer that questions, there will be a problem with R-square, because as long as you add one more independent variable into the model, R-square will increase, and it will make us feel better about the model. But in fact, it may not. Okay, in fact, it may not. If the new variable that we add into the model does not have an effect on the dependent variables. Okay, so that is the problem with R-square. Model with more term may appear to have better fit. Okay, better fit, that is the fit between the sample regression model and the sample data, not the fit between the population regression model and the population. Okay, and remember that we care about the population, not the sample. So trying to make R-square high may lead to the population regression model not reflect well the population. Okay, and too many predictors and higher order polynomial will lead to overfitting the model and misleading high R-square and a lessened ability to make prediction. Okay, I guess that it will be a little bit difficult to understand here. Okay, so I will use Vietnamese to explain this situation to you, so that you will get better understanding of it. Okay, với A square ở đây nhé, với cái thằng A square ở đây thì các bạn có thể thấy là nó chỉ cho chúng ta biết cái mức độ phù hợp giữa cái đường hồi quy mẫu đối với cái bộ số liệu mẫu mà thôi, đúng không ạ? Nhưng mà cái chúng ta quan tâm ở đây là cái mức độ phù hợp, đúng không ạ? Khi mà chúng ta nghiên cứu một vấn đề thì chúng ta quan tâm đến tổng thể chứ chúng ta không quan tâm đến cái mẫu. Vì vậy cho nên là cái mức độ phù hợp giữa cái giữa cái mẫu với mô hình hồi quy mẫu với số liệu mẫu thì nó không thực sự là quan trọng, đúng không ạ? Rồi, thực ra thì nó càng cao thì chứng tỏ là cái mức giải thích của cái đường hồi quy mẫu đối với cái số liệu mẫu thì nó lại càng tốt, đúng không ạ? Và khi đó thì chúng ta có nhiều niềm tin hơn, đúng không ạ? Chúng ta có nhiều niềm tin hơn về cái sự phù hợp của cái đường hồi quy mẫu này hay là của cái đường hồi quy tổng thể với cái số liệu tổng thể, đúng không ạ? Nhưng actually là nó chưa chắc đã là như vậy. Rồi ạ, khi mà các bạn A square nó gọi là một cái hàm tăng lên, đúng không ạ? Là một cái hàm không giảm của số biến độc lập ở trong mô hình. Tức là khi mà các bạn cứ thêm biến độc lập vào trong mô hình ấy, thì A square của chúng ta nó sẽ tăng lên, hoặc ít nhất là nó sẽ không giảm đi. Nó sẽ không giảm đi khi mà, tức là nó không đổi, khi mà cái hệ số ước lượng ứng với cái biến độc lập ấy, mới thêm vào ấy, nó bằng 0. Được chưa? Còn khi mà cái hệ số ước lượng ứng với cái biến độc lập nó mới thêm vào, nó mà khác 0 ấy, đúng không ạ? Thì các bạn sẽ làm sao? Thì các bạn sẽ chắc chắn là A square của cái mô hình nó sẽ tăng lên. Được chưa? Nó sẽ tăng lên. Rồi, thế thì nó sẽ dẫn đến một cái vấn đề là gì ạ? Với các cái mô hình hồi quy đa biến thì như chúng ta nói là chúng ta có muốn có các cái nhiều biến ở trong mô hình để giải thích cho cái sự thay đổi trong giá trị của biến phụ thuộc. Vậy thì nhiều biến ở đây thì tôi sẽ chọn những cái biến nào? Những cái biến nào tôi nên cho nó thêm vào mô hình và những cái biến nào không? Với A square của chúng ta ấy, thì tất cả các biến cho vào mô hình đều tốt, đúng không ạ? Bởi vì sao? Bởi vì nó làm cho A square của chúng ta tăng lên. Thì làm cho A square tăng lên thì có nghĩa là tốt rồi, đúng không ạ? Đó, nhưng nếu như các bạn sử dụng cái tiêu chí A square để chúng ta xét cái việc đưa thêm các cái biến vào mô hình, thì câu trả lời lúc nào cũng là đưa thêm biến vào đi, đưa thêm biến vào đi. bởi vì nó sẽ làm cho R square tăng lên, đúng không ạ? Thế nhưng mà cái việc mà chúng ta overfitting cái mô hình hồi quy mẫu với cái số liệu mẫu như vậy thì nó rất có thể sẽ dẫn đến là cái mô hình hồi quy tổng thể nó sẽ kém fit với cái số liệu tổng thể của chúng ta, đúng không ạ? Đó, để chính vì vậy cho nên là gì ạ? Ở đây thì cái việc R square nó là một cái thằng, nó như thế nào nhỉ? Nó là một cái criterion, nó không phải là một cái criterion tốt để xét cái việc đưa cái số liệu vào trong mô hình, đưa vào cái biến độc lập vào trong mô hình, đúng không ạ? Bởi vì sao ạ? Không phải lúc nào việc đưa biến độc lập vào trong mô hình cũng là tốt. Cái việc đưa biến độc lập vào trong mô hình, thêm vào trong mô hình để giải thích cho biến phụ thuộc sẽ là tốt nếu như cái biến độc lập đó thực sự có ảnh hưởng lên giá trị của biến phụ thuộc, đúng không ạ? Thực sự có cái mối quan hệ giữa cái biến độc lập đó và cái biến phụ thuộc của chúng ta ở trong tổng thể. Còn trong trường hợp cái biến độc lập đó nó không thực sự có ảnh hưởng đến biến phụ thuộc ở trong tổng thể thì cái việc đưa biến độc lập đó vào trong mô hình sẽ dẫn đến cái mô hình hồi quy tổng thể của chúng ta nó sẽ bị làm sao? Nó sẽ bị unfit, nó sẽ bị kém phù hợp hơn với cái số liệu tổng thể của chúng ta. Đúng không ạ? Vì vậy không phải lúc nào đưa biến độc lập vào trong mô hình cũng là tốt. Cái biến độc lập đấy nó chỉ tốt khi mà nó thực sự có ảnh hưởng đến giá trị của biến phụ thuộc ở trong cái tổng thể của chúng ta. Được chưa? Đó. Thế thì vì vậy cho nên là đây chính là cái vấn đề với R bình, đúng không ạ? Với R square thì cứ thêm biến độc lập vào thì R square nó sẽ tăng lên. Vì vậy cho nên là khi mà tôi muốn xét cái việc là có nên đưa biến độc lập này vào thêm hay không thì tôi sẽ không dùng cái thằng R bình này nữa. Được chưa? R bình thì nó vẫn report cái mức độ phù hợp của đường hồi quy mẫu đối với bộ số liệu mẫu. Nhưng trong cái trường hợp khi mà chúng ta muốn xét cái việc đưa thêm biến độc lập vào trong mô hình thì lúc đấy các bạn sẽ không dùng được R bình nữa. Có hiểu chỗ này không ạ?
Có ạ.
Yeah, okay, good. All right. Tobias and King, if you have any questions regarding this, you can send me a message in the inbox, or you can send me an email. I will explain it more clearly. Okay.
I have a quick question.
Yeah.
I have a quick question.
Yeah.
Does the independent variable, must the independent variable has a causation relation with the dependent variable, or correlation is good enough?
Actually, correlation is not enough. Correlation is not enough because we, as we see, regression model. We built the regression model based on the relationship, based on economic theories, based on previous researches, not based on the data. So the correlation is just from the data itself, not from the theories or the results of previous researches. So here we need the independent variable has to have a causal link with the dependent variable, not only correlation.
Okay, so here it gets a little complicated because, for example, Keynes, when he wants to prove the consumption income function, he has to collect data, but he just has his subjective opinions on that function. Like he proves it with his own knowledge. So how does he preemptively know that the data he collects are causation? Because without the previous research, it's just a correlation at best.
Yeah. So can you repeat your questions because your signal is not so good. I cannot hear it clearly.
Yeah. So I want to put an example here. For example, Keynes, when he proved the consumption income function, he just proves the causation in the function with his own knowledge. To my knowledge, he does not really reference the old researchers because he's like the first one to ever does that. So here's my question: with his own knowledge, his own reasoning, can he acknowledge preemptively that the relation between the two variables are causation?
Actually not. Usually we have to, in order to build a regression model, as I say, we have to base on economic theories or previous researches. Previous researches maybe quantitative research or qualitative research. Usually if there's no previous researches about this problem, they usually have to do quantitative researches to see whether there may be a relationship between them first. Then you will use the quantitative research with model to prove that idea again. Okay, so if you do not have previous researches, but what are your variables? What are your variables that you say that there's no previous researches?
Yes, the variables are consumption and income, with income being the independent variables and the other being dependent. So
Yeah.
Keynes, to my knowledge, he's like the father of that function. So he basically proved the causation. So I'm kind of question his
Okay.
method.
Actually, about Keynes. So before he before he have that theories, he have to do plenty of researches about that problem already. Okay. uh, in scientific researches, we have the methodology to do a research. If you want to develop a theories, he will have to do plenty of plenty of tasks or researches before he can develop that theory. Okay, that is not because he think of that he have his own reasoning or something like that. He have to do research on many entities of the population, and then he can draw that conclusions. Okay, not because he think that.
Yeah, okay, I get it. Thank you.
Cô có thể nói ở đây một chút là với những cái người mà người ta đầu tiên người ta develop cái theory ấy, không phải tự nhiên mà người ta nghĩ được cái theory đó đâu. Ở trong cái scientific research, trong nghiên cứu khoa học ấy, thì người ta có hai cái loại, đó là qualitative research và quantitative research. Thì với cái hai cái thằng này nó sẽ có một cái mối liên hệ với nhau, đúng không ạ? Như các bạn thấy thì với cái quantitative research, các bạn sử dụng các cái model, thì các cái model đấy nó phải base vào các cái cơ sở khoa học, đúng không ạ? Cơ sở khoa học thì có thể là theories hoặc có thể là previous researches. Thế nhưng mà trong trường hợp mà chưa có theories, thì trước khi mà người ta có thể xây dựng một cái mô hình như vậy, thì người ta sẽ phải thực hiện các cái qualitative research, thực hiện các cái nghiên cứu định tính để người ta thăm dò, đúng không ạ? Người ta thăm dò, người ta phát hiện rằng liệu rằng có thể có các cái mối quan hệ như vậy hay không, đúng không ạ? Người ta sẽ phải làm cái điều đó trước khi mà người ta xây dựng các cái mô hình hồi quy để mà người ta kiểm chứng lại cái điều đó, chứ không phải là tự nhiên người ta nghĩ ra được cái đó. Nó phải có các cái cơ sở khoa học thì chúng ta mới có được những cái đấy. Thì cái việc mà người ta nghiên cứu các cái nghiên cứu định tính ấy, đúng không ạ, để mà thăm dò, để mà phát hiện ra những cái mối quan hệ, đúng không ạ? Người ta có thể nghiên cứu một cái mẫu như thế này. Ví dụ nếu mà sau này các bạn có học cái môn phương pháp nghiên cứu khoa học thì các bạn sẽ thấy cái điều đó, đúng không ạ? Chúng ta sẽ phải thăm dò, chúng ta sẽ phải tìm hiểu từ những cái mẫu nhỏ, đúng không ạ? Rồi rút ra những cái quy luật gì đó từ các cái mẫu đó, và chúng ta sẽ dùng các cái nghiên cứu định lượng, đúng không ạ? Các cái mô hình để chúng ta kiểm chứng lại điều đó, đúng không ạ? Và thậm chí là chúng ta có thể dùng cái qualitative research để chúng ta explain, chúng ta giải thích cái cơ chế tại sao mà tại sao mà chúng ta lại có thể có được cái, tại sao mà cái thằng này nó lại có tác động lên cái thằng này như thế này, đúng không ạ? Tức là cái qualitative research của chúng ta vừa có thể là cái khai màn, đúng không ạ? Cái định hướng cho cái nghiên cứu định lượng, mà nó cũng có thể là giải thích thêm cho cái kết quả của nghiên cứu định lượng của chúng ta, đúng không ạ? Đó, thì với cái nghiên cứu định lượng của các bạn ấy thì nó sẽ phải, để mà chúng ta xây dựng được cái regression analysis thì các bạn cần phải có cái cơ sở phía trước, được chưa? Không phải tự nhiên mà chúng ta nghĩ ra được. Ok.
Okay, thank you.
Yep. Any other questions? Okay, so our lecture will end here. Okay, next class we will continue with multiple regression model, and please think about the factors that you can add into your your project. Previously, you have two variable regression model already. Okay, you have developed the two variable regression model. Now, please find more independent variables to add into your model, okay, to explain for your dependent variables. Okay, that is for the group work. All right. Okay, we will talk about the group work maybe in the next class. Okay, any questions? All right, so goodbye. See you next week. Have a good weekend. Okay, if you have any questions, you can send me an email or send me a message. Yes?
Goodbye, teacher.
Thank you.
Yeah,
Have a
see
great
you.
meal.
Goodbye, teacher.
Yeah, great weekend.